welcome Rene for this podcast. This is a kind of a podcast where I was always waiting for. Trust me, AR, MR, XR is the new experience that we are going to pursue tomorrow. It's all about the ways in which we are perceiving the technology, the way in which we are using technology. Of course, this technology has the intent of working more towards the AI, ML, computer vision aspects. But here, what this technology means to the industry, that's what we are completely demystifying through this podcast. And this podcast is going to be one of the most exclusive ones because this is my first podcast on the mixed reality, virtual reality, and the things like that. So stay tuned, folks, for an awesome set of gyan that you are going to get from this podcast. And thank you so much, sir, for giving me this podcast.
Yeah, thanks for having me. I'm happy to be on the show here to talk about spatial computing, AR, VR, MR, whatever you want.
Yeah. Let's just going on, like, let's just rewind back and for a time and let's just think of the 15-year-old Rennie. Had you really dreamt that you will be working in this field of AR, MR, XR, whatever it is, the reality which we are just creating with respect to the technology? Like, did you really dream that you'll be working on this technology tomorrow when you were 15?
Yeah. With 15, no. Not at all. Like I could not have imagined to be working on things like HoloLens device and other fancy setups and so on. I mean, I was always a geek. I was always like working with computers and so on. Well, when I was 15, not so much. That was my teenager years, so that was a different story. But like from a kid age or so, the first computer we had that I used was a Commodore Amiga 500. And that shows also my age here. And so the younger attendees won't remember that, but you can look it up on the web. And that was like one of these computers that a lot of folks had back then. And so we were exchanging floppy disks with copies of software and games mainly. But then I started my first kind of like, what can I do? And I did a little bit of assembly language on the Commodore Amiga 500. I was always inspired by the demo scene. Like that was a big topic on Amiga and Commodore platforms in the end. And there's this thing, demo scene, you can look it up, but it's pretty awesome because like these were some hackers in the end that built some really fancy visuals. And before a game launched, for example, it came out of the cracker scene actually. So folks that crack these games and applications, that you could just copy them, like with pirated games and so on. And so what they did in the demo scene, like how they started these crackers, they made little intros at the beginning of these kind of games so that they could see, hey, we hacked this one. And so you had this kind of wobbling text, and that kind of stuff. This is how it started. And so this got me attracted a lot into computer graphics, because this was like state-of-the-art computer graphics. Like some of these intros and later on you had full demos, like no cracking, but like a full visual demo with a lot of music and a lot of like visuals and really amazing stuff. That really gave me kind of inspiration for getting into computer graphics, like 3D programming and all of that fancy stuff. And then later on I studied computer graphics or computer science, media and computer science at the university here in Dresden. And the rest is history, kind of always like really deep into computer graphics, 3D development, physics simulation, all the heavy stuff, if you will, but it's what is so visual, right? It's so rewarding if you do something with 3D computer graphics, like, if you use Unity as a game engine or an engine, for example, which we will cover later on, I guess, as well, how you can develop for it. But if you use Unity, it's easy to get started. You see some, like, even if it's just a simple rotating 3D cube, right? You have a 3-dimensional cube and it's rotating and you see it the first time, although, you hacked some vector algebra and some things like this. And then you see that it's so rewarding to get this visual feedback. And that is always a big motivation, right? But basically going a little bit beyond that, studied for a bit and then working, I don't know, like since 15 years or something professionally started as a software developer and then more of a lead developer, and now I'm director of global innovation at Valorum Reply. And so all of these things, that's what I cover basically, spatial computing with, which I'm going to explain later, quantum computing, AI, computer vision. This is the kind of stuff I'm looking into, basically building ground knowledge so that they can take it and Valor and Reply to build solutions for our customers, because we basically do consulting, build custom solutions, also soft system integration. That's what we do at Valor and Reply. And it's good fun. We also have been working with the HoloLens since 2015 and did a lot of work in that space. I'm also a Microsoft Regional Director and MVP. These are awards that Microsoft provides for community leaders that are independent and share their knowledge. So I do a lot of conference talks. If you want to follow on Twitter, it's RSCHU. Constantly keep on sharing stuff there. Also feel free to connect in LinkedIn and whatnot, where I always keep on sharing like things that are doing, like concepts, but also demos, and sharing the knowledge basically. And a lot of that is related to Microsoft technology, and that's being rewarded with these kind of awards since, I don't know, more than a decade. Definitely as an MVP, started with Silverlight, Windows Phone, all of that stuff, and then always with a focus on computer graphics, shader development. And now I'm a mixed reality MVP and also regional director, which is a even smaller group. But anyhow, I'm also advisor for the VR and AR Association, as well as XR Bootcamp. Look at this. This is the XR Bootcamp calendar here. This is Baby Yoda wearing a HoloLens. I mean, this is just fantastic, right? But anyhow, XR Bootcamp are doing these kind of learning paths for becoming, kind of spatial computing designer, developer, whatever you have it. And so helping a little bit with advice there. That's Rene.
Yeah,
and we have I have a family here in Dresden. I'm married and we have 5 kids.
You are such a happy soul that I always feel that like I want to be somebody like you one day. Like just being that happy, just going on, just thinking of nothing else, just giving back to the community. That's what it's all about. Like, you work in the MR, VR, and all these aspects. Like, what's your professional life all about? Like, is it all about like thinking creative only, or is it about the tech only? What is it all about? Like, many people who want to enter this field have this doubt, like, should I be good in the creative side? Should I be good in the technical side? What is it all about?
Yeah, I think the best is if you have multiple skills, in fact, and are not just like your pure technical thinker and not just your pure design thinker, but also have some, at least a little bit of knowledge from, well, the other field, if you will, right? Although I tend to hate to put these boundaries there, but typically if you're looking into development or engineering role, like there's always these kind of like boundary, and designers, oh yeah, they make it beautiful, right? And then designers might say, oh, the developers, they just write some code and blah blah, right? It's always this kind of like fight between those groups, but the best people actually unify those skills, or have at least some of the other side, and fully understand. In fact, at Valorem, we have a role that is called an integrator. That is basically a person that has design and development skills. They have both. And so what they do is, when we do a software project, and for example, there's a nice UI design that a designer created, an interaction designer created a nice design, and then you have to implement that, and then this is where the integrator comes into play, because they understand the design very well, and they can put it one-to-one in code, basically, or in whatever markup language you're using, XAML, HTML, whatever it is, could be, I don't care, right? But somehow basically transferring that between those. And like for myself, I describe myself as a creative developer, creative thought leader as well, because sharing the stuff, but also building things. Although not writing so much code these days, I try to tinker a little bit around. But what I do is like really looking at the market. And I also take signals from like Gartner, Forrester, and these kind of market research reports, right? You have these market research companies that look into, okay, these are the emerging tech. So like I said, we have these like different roles, right? You have the integrator role that can integrate some great UI designs into the code. So the best people basically always have an eye for all the things, basically, because you cannot just live in your isolated silo, right? You need to see, okay, what are other people doing that I work together with? And so at least having a little bit of knowledge is always good. What I do is I describe myself as a creative thought leader and creative developer, although not writing so much code anymore these days, but like doing more of the groundwork research as well. You know, of course, tinkering around with some things, for example. But I also typically start with looking at market research data. Like you have, you know, Gartner, Forrester, and the other big market research companies that, for example, provide reports like emerging technology report, like what's hot in the next few years. And so I start typically with that. Take a look. Okay, these are like some high level interesting topics, and of course align those with what are the strategy and the vision for the company for Alarm Reply, and then, you know, see, okay, where would it make sense, and then I take these topics and, you know, work through them, and also build some demo POCs with a little team, and then we also take those and put them into like delivery teams that take these to clients, and then, you know, basically do a lot of research. But I also do a lot of like these kind of, you know, giving folks inspiration for their own projects, and a lot of that is of course related to spatial computing, the HoloLens we have here, a couple of other things. But basically, and I guess like my advice for students and you know, young professionals would be, um, don't just be stuck in your silo, right? If you're great in AI, also think about, okay, what are some of the implications of it, right? Or if you're like a computer graphics developer, like, okay, like how can I work with design, or how can I work with 3D artists, and getting a little bit of idea of what other people are doing, and then you will become a really, really good resource, right? Because we are not just working in a silo anymore, and you need to be working with a good team, and of course also work on your communication skills, right? That's typically often forgotten, is like communication is key, right? You can be the best designer, the best developer in the world, but if you cannot explain it, no one will know, right? And so that's important, that you also, you know, can handle that a little bit. So go out, do some talks, right? I mean, there are user groups, meetups all over the place, although a lot of that is virtual these days. It will hopefully come back to being physical, but even virtual meetups and so on can provide really good value. And I would recommend, you know, to young folks to get started, look into some topics you're interested in, find a meetup, or, you know, some kind of user group where you could, for example, deliver a talk about this topic, and then of course work on the topic, learn the topic yourself, and while you learn it in such a way that you can present it to others, what your goal will be, then you will learn it much better than just, because humans learn much better if you explain it to someone else, and that's when you really have to think really deep about it. And so that was also recommendations, like if you want to improve your communication skills, of course, go in social media, you know, connect with each other. And that's also a big portion, is like networking, right? You need to know a lot of people in the field, and yeah, get out, and, you know, starting with some meetups and user groups is always a good advice, I would say.
Yeah, you told about interacting with people, working on different fields, working on different aspects of the development. But on a philosophical note, we are also trying to build a brain on a burning box, like CPUs, GPUs, and things like that. Like, I just want to ask you this one silly question, probably. Like, how far have we realized that the computers run this world today? Like, computers are the main source of intelligence today. Like, how are we exploring it? Like, how are we building it today? That's my question.
So, well, the world runs on computers for sure, right? And we just saw it yesterday when one famous service, middle layer service, was basically not reachable, and a lot of big websites that rely on it were not available. And that's when you really realize, oh wow, actually we're all connected with each other, and hey, oh, what's going on here in this stuff, right? And so the whole world runs on the internet in the end, right? And computers. And so there's a lot of interesting things that we will think about in the future when we enter the quantum computing age, right? I mean, we're really at the infancy still with when it comes to quantum computing, but the current computers, which we call classical computers, won't be replaced by quantum computers, to be clear, right? They will still be useful, and they will, of course, fulfill a certain use cases, and quantum computers will just, for example, expand what's currently possible and provide us with computing solutions to solve challenges that are nonlinear problems, that are exponential problems in kind of complexity. And these are basically impossible to solve with the current classical computers. And with quantum computers, we can solve these tough problems. But not every problem is such an exponential problem. And that's where classical computers will still be for, I don't know, like 90% or 99% of the things we will do. Classical computers will just be fine. But quantum computers are really going to solve key challenges in science that we're not able to solve in the past. And this will make new things possible that we could have just imagined. For example, think about drug discovery, right? Finding new pharmaceuticals, finding new fertilizers, and so on. And all of this quantum computing is based on the physics principle of quantum mechanics. And principles like entanglement or superposition, and these, where you have these computing units called qubits instead of bits, and qubits can have multiple states, and they can be in a superposition state where they're not just 0 or 1 like a bit, but a qubit can be anything in between, and all of that at the same time, which is this crazy concept of quantum mechanics. But we can use that for computing, and with this we can basically compute many things in parallel and speed up these nonlinear problems, these exponential problems, and solve them in linear time. And that's the key here, right? And if we think about especially the case of financials or any optimizations, or even the classical traveling salesman problem, right? Where you need to optimize a route, a certain person needs to visit a bunch of cities. What order is the best? Where can I save the most time? What is most fuel efficient? That's a classical hard problem, if especially, the more stops you add, the more complex it will be because it's exponential. And that is a hard problem. But with quantum computers, I can solve these exponential problems in linear time and provide a lot of cost saving. But also, like I said, for drug discovery, this will really change how this works, how folding works, and all of these complex problems that can be solved with it. And in the end, if we're looking at a little bit of a philosophical standpoint, the interesting part about the kind of quantum mechanics is that our universe, our world, runs on quantum mechanical principles, right? Einstein was still very skeptical 100 years ago, but since then, a lot of these principles of quantum mechanics have been proven. They have been shown in experiments, right? It's not just a theory anymore. They have been proven it's real. And this is how our universe works at the smallest scale, at the smallest dimension, on an atomic or even subatomic level, like electrons, photons, positrons, whatever it is, and even lower than that, like quarks and so on, right? All of these have to work in a quantum mechanical principle way. And well, if we can simulate quantum mechanical problems with quantum computers, then we're getting closer how our nature actually works in the end, right? So if we're getting closer how our nature works and come closer with the computing to it, of course, I think we can solve these problems much better. So this about quantum computing in general, the landscape of computing is changing quite a bit, but no worries, like classical computers and GPUs and other acceleration chips will still be very useful. In fact, we already use quantum computing, like quantum-inspired optimization, not on quantum computers. You can do that, but real quantum computers are very, very small at the moment, not very stable, not really useful. But you can apply these quantum-inspired computing, as it's called, QIC, quantum-inspired computing, and build, for example, quantum-inspired optimization algorithms. And so we developed, for example, one that is called MegaQubo, that we even deployed with clients. And so these algorithms, again, they follow quantum mechanical principles because this is closer to nature, if you will, but they run even on classical computers. So what we can run them on a GPU array, right? In the cloud, you have a bunch of GPUs or some high performance computing, right? You can run these on an array and basically solve these quantum mechanical challenges much faster, even on classical computers, right? Now that's the key here, is like, if we use these quantum-inspired optimization algorithms, run them on classical hardware, they're still faster than your classical optimization algorithms on the same hardware. And now think about in the future, once we have enough qubits with these quantum computers, we can take these algorithms as they are, that we can currently already run on classical computers, and take them as they are and put them just on a quantum computer, and they will work there and fly because they will be even faster. And that's the big promise, right? But of course, like I said, it's a shift in computing and development, because it's a different way how you compute, how you program these computers in the end. But it's an interesting part is you can already use quantum-inspired optimization with a simulation on classical hardware that is already outpacing classical optimization algorithms.
Yeah, I know this is this question I really want to ask because you explained a lot about computing, quantum computing. So, you know, are there any canonical problems that are yet to be solved in the world today? Like they are not yet solved, but they are prevailing from long time. Are there any problem statements that you think has yet to be solved in the world of computing, AI, anything?
Yeah, I mean, there are multiple of those. And if we maybe we pivot a little from quantum computing to spatial computing, and there's a bunch of things you could also do with that, and that help to make the world better in the end. But for if we just finish up on quantum computing real quick, there's so many use cases that are unsolvable today, and what I think is one of the key things that will really have a huge impact on humans on the world and on this planet is a drug discovery, and especially a thing called protein folding, like where you have these like complex molecule structures, these proteins, and in biochemistry they need to be it's a complex problem, but basically you need to simulate how they will fold and so on, right? But anyhow, that is super complex, and there's a lot of these simulations and things are being done in high performance computing or even distributed computing, like crowdsourced computing, right? There's a project called Folding at Home that was very useful also for finding, for example, how the SARS-CoV-2 COVID virus, how that, for example, snaps into the at the cell, right? How it enters the cell. And so you need to compute how it will fold, right? How the S protein outside of the SARS-CoV virus, how it will attach to it. And so you need to simulate that in order to, provide a good vaccine and drug discovery. And so these are big challenges that are being currently really a kind of a stopper and a roadblock for a lot of finding these new pharmaceuticals and chemicals. And I think this will have the biggest impact with quantum computing, that we will be able to do these things and calculations and simulation much shorter time, and we'll also understand much better how the biology works, and in the end also how the universe works, because we can run much larger parallel computing simulations, and that is definitely exciting. Another big challenge I see is in general with computing, not so much related to quantum computing, but more to the user interface, for example, is accessibility, right? I mean, there's still, I mean, we're doing a talk here, right, over the internet, which is already fantastic that we can do this across the globe, but still a lot of people are still excluded from these kind of experiences, right? Because they have, like, for example, I don't know, like low vision or blind people. Of course, they cannot see certain things, right? So it's really tough for them to experience a lot of stuff these days, especially in these remote settings, right? Um, and so there's other things that can be enhanced with accessibility in mind, of course, building a more diverse and inclusive environment. And this is also where we see multi experiences come into play, like natural user interfaces or voice user interfaces. And so a lot of us maybe have some kind of smart speaker, and this is already great, like a voice user interface, but also chatbots, right? Oftentimes with a voice user interface or a text-based interface. And basically where we need to get to provide the highest accessibility is we need to get to these multi-experience solutions, right? Where you can experience a certain solution through multiple input modalities. And that could, and so it would fit and suit all the different users. And so they can be actually used here in this case. And, basically you can build experiences that are fully inclusive if you're applying spatial multi-experience solutions. One of that is, for example, spatial computing, right? One input modality could be spatial computing with devices like a HoloLens I mentioned here, right? So you have, for example, this device, which is, if we think about it, providing us also information about the environment, right? So if you don't see the podcast here on video, I'm holding up a HoloLens 2, and this has a bunch of advanced sensors that you can see on top here, right? So it has all these sensors here, which can track the device in the environment. So the device knows where it is in the room, right? While you wear it on the head, right? So you wear it like this. And another fancy thing is, of course, the displays here. You have these displays here, right eye and left eye. So you have stereo displays. And as you can see, they are see-through, right? So they're semi-transparent. You can see something on this display, but still see the real world around you, right? And this is called mixed reality device from Microsoft HoloLens, because it can blend the real objects like the real world you see with your own eyes, with virtual objects. So this is mixed reality. Then you have augmented reality, which we often experience on mobile devices like a smartphone, right? And so then you see the AR experience on top of your display. You see the camera feed real time, and then virtual objects on top of it. Well, and then we have virtual reality, right, where you're fully immersed in a virtual world. You don't see the outside world anymore, but you're fully in a virtual environment. And then we have depth sensors like an Azure Kinect that can measure the distance to object and understand the world around us. And now wrapping that up all together, well, this is all spatial computing, because these devices are spatially aware, right? This device, of course, very much so, because it has also a depth sensor and all these tracking cameras. So it knows, okay, there's a ceiling there's a wall here, a floor there. But even these mobile phones like Android with the AR Core API set, or on iOS with the AR Kit API set, they understand the environment also to some degree. Of course, not as much detailed as a device like a HoloLens, but I was just playing around with some new SDK. I got access, and it provides me a really good spatial map already on these devices. And it doesn't even have to be the latest and greatest. Like, let's say every device that came out maybe in the last 5 years or so has AR Core or AR Kit capabilities. And so they can reconstruct surfaces. They can, for example, reconstruct horizontal and vertical planes. And so they understand the environment around you. They do this 3D reconstruction real time. And this is why I call it spatial computing. These devices are spatially aware. They know where they are in the environment and can then provide contextual information to the user, right? So they're not just looking on your phone and, well, connected to the internet, but your phone is also connected to your current environment. So it can show you contextual information right in front of you, because it understands your environment, not just via GPS, not just via Bluetooth or Wi-Fi, but via computer vision, analyzing the camera frames, right? It can compare then, okay, was I here before or not? Maybe someone else like Vishas was there and left like a hologram or whatever virtual object in the real world, right? Now Rene comes to the same spot, just scans a little bit, so it knows the device where it is, and then whoop, it can load that information. And this is the key here when we're talking about spatial computing and this thing called the AR cloud, this augmented reality cloud, where we take all of this spatial reconstruction data, bring it together in the cloud, merge it, and then we have this unified reference map of the real world, kind of a digital twin, like a digital content layer on top of the real world, where we could then anchor virtual objects, right? Like I just explained, I could put a virtual character wherever I want, and then it would work indoors and outdoors, because we're not relying on GPS or any radio frequency signals, but in fact we're relying just on the camera data, right? And it doesn't even have to have a depth camera. It just works just with monocular RGB sensors. And this is really thanks to all the amazing progress we have seen with computer vision AI in the end, right? Because they can reconstruct the environment, extract useful information, then the power of the cloud. And this is really exciting, because I think a lot of these basic principles, they all come together now, right? We have all this computer vision AI progress with these advanced algorithms. We have really amazing hardware progress in terms of what they can compute on these devices. We have amazing cameras on these devices. We have great connectivity with 4G and of course 5G coming. And there's even 6G being talked about. In fact, like in the city I live here in Dresden, Germany, there's a research facility a lot for 5G, and now they also said they're working on the 6G, right? So it's pretty interesting. Well, to wrap it up, all of these things come together now, and we can provide really interesting solutions for everyone. And that's the key here, is like, these spatial computing experience, like I said, they can sense the environment, right? And so they also provide a higher accessibility for everyone, because they can provide contextual information for everyone. And this could be via audio output, that could be a visual, like something you see, but it could also be spatial sound, where you wear like headset, right? And you could hear where sound is coming from in the real world. And all of these things really help, because we have an understanding of the real world and we can connect it via the AR cloud.
You told about how technologists have found ways in getting this technology to be accessible for the world. But I want to ask you, like, how are people perceiving this technology? Like, how are they happy about the technologies that are coming? Because I'll say you what, because I read a lot of papers from ArcZab, I read a lot of papers from different sources. I feel that technology is getting more accessible today than what it was like 5 years before, according to me. Like, how is people perception over the technology today?
Yeah, that's an excellent question, and something I'm very happy about, that this technology is becoming more accessible, and also not just more accessible, but also the research is open these days, right? I mean, for not everything, of course, but especially when you say archive or so, right? You see a lot of like AI papers, a lot of papers that are related to computer vision, and most of the computer vision, if we look into the past, it was handcrafted. It was handcrafted computer vision. You had algorithms, that would follow a certain principle. But these days, most of the computer vision research that is ongoing is deep learning based, right? You have neural network models for computer vision tests, object detection, object recognition, I don't know, like, body segmentation and all of that fancy stuff. And we have all of this now running on all of our smartphones. And so this is so exciting because we can build these 3D reconstructed map of the environment real time, and use that information, like I just said. um but it would not be possible with the progress of the AI research. And the AI research, some of it call it the renaissance of AI. And I was doing AI deep learning projects 15, 20 years ago, and at my university research, and that was the winter of deep learning. Like, this was like when folks were saying, no, this is not going to work. And then we have now the renaissance of deep learning since, I don't know, 7 years, 5 to 10 years, something like this is really when it started gaining momentum. And I see three things here while this is the renaissance now. First of all, we have much more computing power, right? We have like super powerful GPUs. And funny enough, GPUs were mainly developed for, computer graphics, right? But these days, GPUs are being outsold because they're being used for deep learning training and so on, right? So it's an interesting take. And if you look at NVIDIA and or AMD and all the big companies, I mean, if you look at the graphics card, they now have dedicated kernels and computing resources just for deep learning mainly, right? And so this is one thing, right? We have much more processing power available. The second one is, of course, all the data, like all the data that is now available, right? We have all the social media and the internet in general. I mean, it's a huge database of, it's a huge library in the end, right? And so we have this availability of data that we need, because deep learning and training, as it is, training has it already in the name, right? You train these models with data, and you need a lot of data to have a diverse data set. Also important for accessibility and being inclusive, that we have a very diverse data set and not just focus on certain objects, but have the whole world population covered, for example, for face recognition, because otherwise it would not work really well for certain kind of people, right? And so that's a big challenge. And so the second success is, of course, after hardware, the second one is the data availability, big data, right? And the third one, which might be the most important one in the end, is the open research that is happening, right? Back when I was still at university, most people were working on their own. Of course, you had these conferences, you were exchanging papers and whatnot. But now these days, like you said, on archive, I mean, most people just like, they wrote the paper, and before entering it to a peer review, or maybe everyone uses a different process. But anyhow, you have these papers available, first of all, which was a tough back in the days. You had to search for certain researchers on their website and maybe find a paper, but oftentimes you couldn't download the paper from them. You had to buy some conference book, and then you would have this paper in there. But these days it's all open, and a lot of that is not just the paper and the theoretical principles behind the solution, but oftentimes it also comes directly with code, with source code, and you can find it open source on GitHub. And so other researchers can take that as a basis, right? And don't have to reinvent the wheel all the time. And so this highly speeds up, of course, the progress here when we are talking about computer vision and AI. And like I said, I mean, this is all fueling these kind of experiences for spatial computing in the end, and a lot of other things, also autonomous vehicles. A lot of these things are just not possible without AI, deep learning, and software in general.
Yeah, because you talked about the self-driving car, which is also my favorite field. Even today, if you just say me self-driving car, hey, Vifas, just give a session on self-driving car. I'm ready with the slides. I'm ready with the demos. Like, I just go and just give that session. That's how, the technology is accessible today. Like, people
Yeah.
are more towards the technology. You talked a lot on spatial computing, which is, you literally told what's the difference between VR, AR, and the spatial computing. Like, what's the amount of challenge that is there today? Because we are all moving more towards the edge computing. Edge is something which is the new trend and a new revenue source also, because every time you can't afford cloud, so edge is the new way of computing today. So
Yes.
like, I just want to ask you, what are the challenges involved in spatial computing today?
Yes. Challenges are mainly, I would say, hardware related. Because these are, if we, like you just said, edge computing, edge AI, and of course that is super relevant, right? So for all the listeners that are not aware of what that actually means, if you look at to Satya Nadella from Microsoft, like CEO, right, when he talks since a few years now, he always talks about the intelligent cloud and the intelligent edge. And so you have this the cloud, right, that lives in these data centers, if you will, and you have some AI workloads, and that's why it is the intelligent cloud. But now this is moving closer to where the action is actually happening. So you don't do the computing only in the data center, but actually closer to, for example, in the factory, right? And so you would have like a mini data center there, if you will, and this is the edge cloud. And then you can even move even closer, right, to the actual hardware. And if you look at this device, this is an intelligent edge device. I mean, this is the HoloLens 2 I hold up here, and this is definitely an intelligent edge device. It does all the computing on it here, right? It has a battery pack, it has computing built in here at the top, and no cable needed, right? This is fully standalone and untethered device for, well, spatial computing. Of course, like I said, some call it augmented or mixed reality, but I call the umbrella term spatial computing because it includes much more experiences and devices. It's not, and like I said, these kind of devices fully untethered do all the computing, and so this is an intelligent edge device in itself, of course, right? Because it has a so-called HPU built in, so it has a CPU, a GPU, and also HPU, which is another accelerator chip, which is called holographic processing unit, fancy name, but it's basically an AI acceleration chip. Because they run all these computer vision in real time, right? Spatial reconstruction, like as you can imagine, it's a huge amount of data. It's incredible amount of data from all these sensors to process that through deep neural networks. And so you have that built into this kind of special chip that can run these workloads much faster. And that is the key here, right? To have a very good real-time solution. But of course, it's still, well, you could wear it for a few hours, but nothing you want to wear the whole day, right? So it's still kind of bulky, if you will. What we want is something like this. I mean, this kind of size of glasses, this is what we want in the future, right? And so there is a lot of things happening where we cannot see only like intelligent edge devices like this one, because it is really an edge device. It doesn't need computing in the cloud, but it can be enhanced with computing in the cloud. It can be, for example, like the AR cloud, I think I mentioned, right? There's a thing called Azure Spatial Anchors. And of course, this needs the cloud, right? You put an anchor here, you share it with your friend that is on mobile, for example. They need to somehow, access the data via the AR cloud. And so this is where it's really interesting to bring in the cloud for these kind of solutions, but also for other things, like I just said, the form factor, right? If we want to get to this kind of form factor, we need to think about, okay, we have certain physical limitations for, shrinking the hardware, but maybe we can offload some of the heavy lifting into the cloud. And so there's a technology that is super relevant, which I'm currently looking into a lot. It's called remote rendering or cloud rendering. And so instead of rendering your very complex 3D model, like think about you have a 3D model of a really fancy car, and you want to visualize that with really good visuals, right? It should be reflected, so it would use ray tracing and global illumination. It would look really lifelike. And that is not possible if you have reduced computing availability like you have on a fully mobile device like this, right? Even mobile phones cannot handle that. And so you would need a very powerful graphics card. And thanks to remote rendering, I can run this. I can use the computing in the cloud for rendering that complex scenery in the cloud and then streaming the result back as a video for the left and right eye. And then you can see it real time. That's also things like Google Stadia was been using or tried to use for the consumer, for gaming and so on, right? But I think it's even more relevant for these professional use cases and enterprise use cases, because a lot of the clients we work with from the enterprise, they already have 3D designs of their objects, right? If you build a new car, if you build a new car engine, whatever it is, it's all starts typically also with computer-aided design modeling, right? 3D modeling in the end. And these models are super, super detailed. Like they're so complex, you cannot render them on a mobile device, but you can render them in the cloud. And that is the promise of remote rendering, where we can bring all of the data, take the power, take advantage of the cloud basically, and combine it with the intelligent edge, right? So basically offload some of the heavy lifting where you can live with a little bit more latency, offload that into the cloud, and then use real-time, inference and so on the actual device itself, on your intelligent edge device, for all the things where you cannot spend a lot of latency, where you cannot send all that data, right? And another example of the intelligent edge is a device I just showed here before. So this is a Raspberry Pi, and it has an Adafruit. It's turned off now, but it has an Adafruit board on top, so it has a little display and all of this. So this is a computer, right? If you have not used a Raspberry Pi, it's a fully standalone computer. You can install even Windows on it, right? But typically it's some kind of Linux distribution, Raspberry Pi OS, right? And also has a little camera, as you can see here, right? So I'm tinkering around with this, and it can run computer vision AI models directly on this little device. So I can build this, wrap it up, and can build like an object recognition or workplace safety solution, which just runs standalone. And this can be built for, I think the whole kit is $150 US dollars, right? And so you can build this whole object detection AI solution, which doesn't just need power, right? And it will run on the edge, doesn't need to send anything into the cloud. And that is fantastic because lower bandwidth, face less latency, right? Less delay, because you don't need to send the camera frames into the cloud for detection. You can run it directly on the device. And the third one being privacy, of course, right? You don't see it send any camera frames into the cloud. That's not what you want to do. You want to keep them on device for having the highest privacy, because no one wants to have their, I don't know, face, stored in the cloud and all of that stuff. Because this is what we always need to keep in mind, which I'm also a big advocate for, is ethical usage of AI, because this is very much relevant these days, right? There's a lot of bad things you can do with these amazing tools, but fortunately, most people are just using it for the good cause and making the world better.
You talked a lot about the AI, spatial computing. You also talked about the potentials of this computing aspects. But I want to ask you, how can we redefine human capabilities today? Because trust me, because these are the kind of technologies that we are looking forward to, because there are people with a lot of disabilities. I interviewed a guest who was having cancer. I think she literally told, people might go behind money, but there is something beyond money also. So I want to ask you, like, how can we really redefine the way in which human capabilities and possibilities of exploring something new from a human being can be redefined using the VR and the AR technologies?
Yep. So we already covered on the part of accessibility a little bit. This technology with, like I said, having all these sensor information and having all this data around us, they can also provide much more meaningful experiences to users to enhance and provide a broader accessibility for everyone. um and also, like, cancer, for example, like you just mentioned, this is where, like I said, all these new drug discovery will come into play, right? Maybe in a few years, I don't know how long it will take, but I'm very optimistic that like this decade, the 2020s, it will be about spatial computing. We will see much more spatial computing devices coming out and solutions, right? Thanks to the powerful computer vision AI, but even more so the advancements in hardware, shrinking form factors, and all the rumors around Apple and all of these other companies that are going to enter the market. When it will happen, I don't know, maybe a few years, but I'm pretty sure it will happen in this decade, in the 2020s. And so this is why I call this is the age of spatial computing. This is not just the age of the pandemic, this is the age of spatial computing. And we will see a big transformation, I think, in terms of human machine interfaces, right? Where we have directly interaction thanks to spatial computing and the augmented reality cloud, providing this kind of digital twin of the world where we can enhance and see productive things. But like I said, cancer is really interesting because, quantum computing, drug research, discovery will be accelerated quite a bit. And so I guess in the next few years, we will have quantum computers from, all the big research facilities, and all the big tech companies are having their own quantum computing hardware research. And they're all working heavily on it. And I think in the next few years, we will see definitely true quantum supremacy, right? Where we have quantum computers that can solve certain problems much faster than classical computers can these days. And once that has happened, the switch will be basically, okay, let's find these new drugs, and then it will happen quite quickly, I think, where we see a lot of advancements in how to improve human life and to make our world much better. And we might find certain drugs for, or vaccines even, for kind of solving certain cancer types. Of course, not everything will be perfect, not everything will be solved, but I think we're getting there quite fast. And I'm very optimistic that in the 2020s we will see a lot of that happening, and a lot of that will be changing how we interact with the world. Also, thanks to brain computer interfaces that are also on the horizon, right? Who knows how long true powerful BCI, brain computer interfaces, will take, but they're coming. And also for making blind people see again. Like, this is a really crazy stuff that is happening, and there's a lot of research, right, where they can connect electrodes again and kind of stimulate all these sensors in the brain to actually get blind people some kind of vision back. Of course, not full vision at the moment, but hey, maybe in a few years we will have something like you see in Star Trek, right, where you put on these kind of goggles and blind people can see again. And I think this is what all of these things, although they're not directly related to all of it, but for example, quantum computing, for example, will be the ground basis for finding these super complex core problems, for solving these core problems, and providing much more, success with solving these issues.
Yeah, last two questions. Trust me, I had a very big session from you, because trust me, this podcast is going to be an amazing journey to the folks who are thinking like, of course, I need to think about the spatial computing, the potentials of it, the problem statements which are yet to be solved in this field. But like, what's the key point in bringing this technology in the world of education? That is like, with the virtual and the augmented reality, move us into the knowledge age. Like, can it really influence the way we are getting educated?
Yes, I think so, especially when we look. I mean, quantum computing is a complex topic, right? Quantum physics and so on. And so but you can even enhance the education with better visualizations. And that is one thing I keep on saying quite a while, because like I said, working with computer graphics since many years, and being in that space, I totally see the kind of challenges that you face while you're learning the core principles, which is linear algebra and matrix calculations and vector, like linear algebra and whatnot. I mean, this is math, right? This is pretty dry when you learn it in school, and what they don't show you is what amazing things you can actually do with it, right? I mean, all of that linear algebra and matrix calculations, computer graphics, but also AI, computer vision, even quantum computing. I mean, there's a lot of these kind of basic principles that apply there, but the motivation that you get in school is very low, because like you don't see the visual outcome, right? So for example, how amazing would it be if we would teach kids math, especially algebra, in a visual way? And so you learn the basics, like you learn what a dot product is, you learn what a cross product is and whatnot. And then you see, hey, now with my cross product, I can now compute this kind of normal, right? For example. And so I have this normal. Now I can light my 3D model, right? But really make it, applied, basically, and not just the dry principles. Of course, you need to teach the dry principles in the beginning, but then you can quickly go into this, hey, look, kids, we can build this amazing stuff. And then you have even like these, I forgot the name, but this is online visual programming tool, which is very popular, which they use for, teaching kids how to code, where you can have these little building blocks and can put them together. And then you can learn the principles of programming. And this is super rewarding, right? You need to get the motivation, you need to get the reward out to the kids and the folks that are learning it. And I think like changing a little bit how we teach certain mathematical principles will also make sure that we have more interest from a diverser group of people for STEM topics, right? For so it's not just like here in Germany, and also in the US and so on. It's still very much a dominated field that is dominated by male people, right? This is really, and maybe if we change the way how we teach it, and change the motivation behind it and make it not just it's such a pure geek topic how it's often seen here in this part of the world. Then we can also increase the diversity and enable more people to be to enjoy that kind of a field. Because maybe as a last thought for the audience is the if you're going to start a career in computer science or whatever it will be, right? It's like what you need to learn in your studies is learning how to learn yourself. That is the most important thing. And then also constant learning. You will never stop learning. It's just the beginning. And take some things that motivate you and stay on top of that.
Yeah, I know. I just want to ask you this question because you have been talking about different technologies, quantum computing, AI, computer vision, and different aspects. But like, what is technology according to you? Because on the edge of reality and the fantasy, I think technology has been learned and perceived in a different fashion. Like, you know, recently I was learning about Azure Kubernetes service. I feel it's so overwhelming. Like sometimes I used to feel like, let me just leave off that topic and just go ahead with some other tools which are available in Azure. So I just want to ask you, like, what's the definition of technology according to you? And in this world of fantasy and the reality, on the verge of being made the technology between the fantasy and the reality, to some people, how are we learning the technology and perceiving it? And what's the flaw that you see in the today's world, which is learning the same technology in different ways?
Yeah, yeah, yeah. Well, it's really the thing where we need to change how we teach certain basic principles. I think I don't know how it is in Bangalore and your area, but here it's still very much pen and paper based, very dry. I mean, pen and paper is really good for teaching certain principles. But I think, like for example, there's a great VR educational software. Unfortunately, I forgot the name that teaches kind of certain principles in a virtual reality environment. Of course, this is quite, we cannot have the kids like putting on VR goggles the whole day and just being in their world. That's just like really bad, right? Don't get me wrong. This is not how we should do it, but rather maybe, provide these little snippets throughout the day. Maybe, just for a few minutes, you can then see what you just built. But I think it's like, what we need to change in the kind of education is like, how can we communicate the motivation, and how can we inspire and motivate young students to build amazing things. And it might take a lot of dry math to learn and a lot of dry principles, but it will be rewarding at some point. And if we can show that to the kids, I think this is a big motivation.
Thank you so much, sir. Thank you so much for this amazing podcast. It's the first time that I did with a guest on XR, MR, and AI, and the reality which we are building with the technology. I think this was the most satisfying day for me because I did learn something new from you. Thank you so much, sir. Thank you so much.
Yeah, no worries. Thank you so much for having me, Vishwas, and have a great one.